Today in class, the students and I worked on tape diagrams and solving algebraically for all four operations with equations. So I'm going to go over an example of each one with you. And I'm going to focus my time on the algebraic method. Okay? From our tape diagrams, the students were able to see that in order to solve an addition equation, they needed to subtract. So the students need to draw a line down the equal sign, separating the equation onto two sides that are equal. And they really have to concentrate on getting the variable by itself and kind of turning this into a zero. And the only way to do that, instead of adding 76, they need to subtract 76. Because when you add 76 to something and then subtract something, it's almost the same as adding 0. So these are going to cancel, and whatever you do one side of equation, the students have learned that they need to do to the other through our tape diagrams. So they are left with x equals 26. And we talked about the importance of checking our answers. So you take the original equation that you were given and substitute the value that you found for x, and you see if it makes the equation true, and it does. Okay? The next we did subtraction. Again, encourage them to draw a straight line down the equal sign. Their goal is again to get their variable by itself. So we have to get rid of this negative 45 or minus 45. And to get rid of it, or to get the value equal to 0, they can do the opposite operation, which is to add 45. Since it's a value of 0, they can cancel. And whatever you do to one side, you must do to the other. So you're left with your variable x on the left-hand side. You drop down your equal sign, and x is equal to 143. Now the students again were encouraged to check by starting with the original equation and substituting the number they found for x into their equation to see if the equation is true, and it is, because 98. Okay, the next, I do want to do another subtraction one. We talked about subtraction and the importance of its order, because solving subtraction equations, addition is not always going to work. In this instance, you have a negative variable. And when we drew a picture of this, if this bar was 57, and you took x away, and it equals 23, this would be the picture. So when you think about adding the x back on, that adding doesn't get you an answer here. This is still an unknown. So in order to solve this one, the students and I talked, and they realized that they still had to subtract 57 minus 23 to get this unknown variable. And that really has to do with having a negative variable. You can't have a negative variable here when we're trying to solve this. So I encourage the students to make it positive. This side would cancel, because minus x plus x, and to add whatever you do to one side, you do to the other. So this equation has just now turned into an addition equation. An unknown plus 23 is going to give us 57. Your goal is still to get the variable by itself here. So I'm going to cancel 23, and whatever I do to one side, I'm going to do to the other. So 34 is going to equal x, and I'm going to check that. I'm going to make sure that 57 minus 34 gives me 23, and it does. Okay, so the stuff we focused on lesson 27 was addition and subtraction, or multiplication and division, and we did pictures as well. But again, I'm not going to focus on that. If you would like to see that, that's in your students' class notes. This is 17 times x equals 51. I've been encouraging the students to expand their multiplication, to never forget that it's there. To undo multiplication, the students saw today from their tapes that they needed to divide to solve. And we are used to drawing division with a division sign or a fraction bar, because fractions really are division. 17 divided by 17 is going to give us 1x. Okay, the coefficient of this variable, even though you don't see it, is 1. And whatever you do to one side, you must do to the other. And 51 divided by 17 gives me a quotient of 3. And again, I still went back to go back to your original equation, substitute the value in that you found for x to make sure that this is a true equation. Okay, and then we did division. So we did x divided by 5 equals 8. I have the students write out the division just so that they remember that a fraction division, it's the same way to write it. We undo division. The students saw today with their tapes was multiplication. Okay, these cancel each other out since they're opposite operations, and whatever you do to one side, you must do to the other. So x is going to equal 40. And then with your check here, you are going to have 40 divided by 5 to make sure it's 8, and 8 does equal 8. There is only one instance where you cannot undo division with multiplication, and it's if your divisor, or if your dividend is first or is not a variable. For example, that was probably pretty confusing since I screwed it up, but let's do 72 divided by x equals 12. Okay. To undo division, most students will be like, okay, I'm going to multiply. So I'm going to do times 72 here. These would cancel, and I would do times 72 here. So when I did 12 times 72, I would get 864. Well, if I check that, 72 divided by 864 does not equal 12, okay? So when the number comes first, or when the dividend is the known, you cannot undo division with multiplication. You actually have to divide. Maybe if I draw a picture of that, 72 divided by x equals 12. So you have some bar that's 72, and you're not sure how many it's divided into, but each section is 12. So you have to add 12 until you get to 72. 12, 24, 36, 48, 60, 72, and that would divide it into 1, 2, 3, 4, 5, 6 sections. So x would equal 6. If the known is first, you actually have to divide 72 by 12 to get an answer of 6. Thank you for watching the video of a sum of today's lesson. If you're watching EduCanon, there will be several review questions at the end of this video.